Hi students, how are you? Hope you are doing well with the chemistry subject. In the previous videos, we have discussed some properties about the metals, and in this video, we are going to discuss how the metals are going to react with water. How the metals are going to react with water. Before I continue with the concept, I want to just recall for the students who didn't learn the arrangement of metals in their reactivity order. I had discussed this topic in the chapter number 1, and again we are just recalling to enhance the key importance of arrangement of metals in their reactivity order. After studying about all the properties of the metals, the scientists had arranged the metals in a particular order. How they react with normal water, how they react with cold water, how they react with steam, and does they react or not. If they are not at all reacting, they call them as the noble metals. Do we know any noble metal? Yes, we know gold. Let us recall the concept that is called metal reactive series. What is the concept? It is called metal reactive series. In this, the metals are arranged in a decreasing order according to their reactivity. The metal that is highly reactive is potassium. After that, we will have sodium. In our previous class also, we discussed that potassium and sodium metals, when we live in normal air, they will react with atmospheric oxygen. Hence, where do they must be stored? Yes, they must be stored or preserved under kerosene, where they will not have any contact with atmospheric oxygen. Followed by, we have the metals like calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. I am not giving the names, I am giving only the symbols. So this is what we call as the metal reactive series. At the top, whatever they are present, these are called as highly reactive metals. What are they called as the highly reactive metals? And then their reactivity decreases down the series. The reactivity decreases. Which is decreasing? Reactivity is decreasing down the series. We can find these are remaining are moderately reactive. What are they? Moderately reactive. Means their reactivity is not very high. They are called as the moderately reactive. What is meant by moderately reactive? We know magnesium ribbon. There is in the chapter number 1, activity 1.1 we had discussed. Before burning, we need to clean with a sandpaper we had discussed, because it is forming an oxide layer over its surface. Which one? Magnesium. And also, we had discussed one more point in the previous video, anodizing. It is the process in which a metal will be covered by a thick oxide layer that prevents it from further corrosion. Can you find out like aluminium? The magnesium and aluminium are also reacting with oxygen, but it is not an highly exothermic reaction, just like potassium or sodium. Here they are reacting with the so-called oxygen, but that is not highly reactive. They are reacting moderately. But copper, mercury, silver and gold, they does not react. So that is called least reactive metals. This is what we have already discussed. And now in our today's class, our topic is how does metals react with water. What is the topic? How does metals react with water? Here, by the name itself, highly reactive metals. In the Discovery channel, you can see some people will be throwing a piece of metal into water and they will be catching the fire. They will be astonished. The reason is nothing but these highly reactive metals like potassium or sodium. Potassium or sodium. When they are placed in water, they immediately displace the hydrogen gas or they release the hydrogen gas along with high amount of heat energy. It is also, we can speak, an exothermic reaction. Which metals are highly reactive towards water? Potassium and sodium. Once you leave in water, they release the hydrogen gas with lot amount of heat. Here one point you must not forget. Whenever the hydrogen gas is near to heat, it will catch fire. So, in the case of potassium or sodium, when they are placed in water, they will release hydrogen gas and a lot amount of heat also they will release. Due to this, the hydrogen gas will be catching fire, and you can see that piece of metal will be burning with fire. I will give the equation for them. Later on, once we see the reactivity of the metal will not be highly much with water. We can see these metals, magnesium, aluminum, or we can see the calcium and magnesium. First let us come with sodium, potassium and sodium. The potassium and sodium, when placed in water, we can see in many ways, like our drinking water. Is it, we say, a hot water? No, we just say normal water. The sodium and potassium reacts with normal water, which is just like the cold water. It's not that we need to take from the refrigerator. Whereas calcium and magnesium does not react with this normal water, they will react with hot water. With what water they will react with? Hot water. Water is the same, but we are increasing the temperature. The metals like aluminum, zinc and iron, they does not react with cold water, neither hot water, but they react with steam. Which are reacting with steam? Aluminum, zinc and iron are reacting with steam. So we can say these are less reactive towards water than potassium and sodium. Hence we can say they are not highly reactive, but they are moderately reactive. Now for this, in our grade 10 standard, we had a very important diagram for the examination purpose also, to show how these metals like aluminum, zinc and iron are going to react with steam. What is the term I am using? Steam. What is meant by steam? The gaseous form of water is called as the steam. Yes. Now let us see the apparatus that helps us, or the diagram that helps us to study how the metals like aluminum, zinc and iron can be reacted with the steam. For this, we have this diagram. Very important diagram for the board examinations. Let us see the diagram. What are the major constituents here? We got one Bunsen burner and also a boiling tube. What did we got? A boiling tube. In this boiling tube, there are different points you must observe. There is one cork. Prior placing the cork, first we will insert a glass bowl to the end. What are we inserting? A glass bowl to the end. Now, major of us will have a doubt. We know bowl, then what is glass bowl? Here, whenever there are two conductors, this is a conductor, this is a conductor. We don't want the electricity to be passed between them. Means we must place one insulator between them. What do we need to place? One insulator between them. Here, the glass bowl is the glass that is made into thin fiber. That is made into thin fiber. It appears like our duster surface. We can see our duster surface, how it is like. In this method, the glass bowl will be. It is an insulator. First point, it is an insulator. We don't want its thermal conductivity now, but it can absorb the water particles in it. What it can do? Absorb the water particles in it. Means we are going to dip this glass bowl prior our activity in the water. So it had absorbed some water into it. The glass bowl that absorbed the water into it, we are inserting into this glass tube, or we can say the test tube. We can use the boiling tube also. So this glass bowl is having the water molecules bounded to it. Bounded to it. It resembles just like the smooth surface of like our duster. Next, in this same so-called boiling tube, after placing the glass bowl, we are inserting the metal sample. What are we inserting? The metal sample. Metal sample means which metals are reacting with? Steam we mentioned, aluminium, zinc, iron. We will not use all the three metals at a time. We will use one metal in one session and another metal in another round, like it goes on. Let us imagine first we have chosen aluminum. So this metal is our metal sample. For that, what we are using to check our experiment. Then we will place one hold rubber cord. What are we inserting? One hold rubber cord. Through that one hold rubber cord, we connect the delivery tube. We connect the delivery tube into a glass container. This was immersed over the water. So that water level was up to here in this glass container. And repeat the point again. One end of the delivery tube is present in the boiling tube, and another end is present in the glass container, which is having the water up to here. And now our boiling tube is held by stand. Boiling tube is held by stand for the support. Now, when you observe the diagram, what are the key points we had? In the boiling tube we had the glass bowl, which is having water particles in it, and also the metal sample, and it is having a rubber cord of one hole connected with the delivery tube into the glass container having water. So once we start the process of heating, this so-called glass bowl will not react, but the water particles that are present into gaseous state, or we can say into the form of steam. That steam is going to react with this metal, like aluminium. To show metals reacts with steam. See, I am using aluminium. Aluminium is a solid. Aluminium is a solid. It is going to react with this water. What is the state of water here? It is in the form of steam we mentioned. It is in the form of the gaseous state. In the form of the gaseous state. Aluminum is going to react with water. Means this is the steam. Then what compounds will be formed? That will form aluminium oxide. What is it forming? Aluminium oxide. Hydrogen gas is evolved. Hydrogen gas is evolved. Here, aluminium oxide being a solid will be here only, but what gas was generated here? Hydrogen gas was generated. That hydrogen gas will pass through the delivery tube and it will be entering into this water. And the gas will occupy the remaining space in the glass container. The hydrogen gas that was released will pass through the delivery tube, will enter into the glass container, and you can observe the bubbles will be raised. The gas will be collected in the container. And here we will be having our hydrogen gas. If you want to know whether that is the hydrogen gas or not, how will you confirm? Do you remember conformity test for hydrogen gas? Yes. Once you invert this container and bring a burning candle or matchstick near the mouth of the container, once we invert it will blow off with a pop sound. It will blow off with a pop sound. This confirms that the gas released is the hydrogen gas. The gas released is the hydrogen gas. Please see which metals are reacting with water we mentioned. The moderately reactive metals like aluminium, zinc and iron are reacting with the water to release the hydrogen gas. Which form of water are they reacting? They are reacting with the steam. They are reacting with the steam. So this diagram, which is very important for the board examinations, you need to practice children. Now I had given only one equation. I had mentioned aluminum is reacting with steam to give aluminum and hydrogen, oxide and hydrogen. Is it a balanced equation you find? No, this is not a balanced equation. In the product, can you could find Al2O3. Al2O3. How many aluminums must be there? 2 aluminums must be there. On the reactant side, how many you had? 1. So balance is for 2. How many oxygens you find here? 3 oxygens. Here there is only 1 oxygen. So shall I make this one as 3H2O? So 2 moles of aluminum are reacting with 3 moles of water, that is steam, to form Al2O3 and hydrogen gas. Please observe 3 moles of hydrogen are there. Means in the product we will have 3 moles of hydrogen gas. Let us take one more equation to show how the moderately reactive metals are reacting with steam. One more equation that we are using here is about, I am erasing the diagram. These are the two most very important equations to learn. One is with aluminum we have discussed. Another one, we are not going to write with zinc, we are writing with iron. We are going to write with iron. Fe, when it is going to react with steam, when it is going to react with steam, it will form Fe3O4 and also hydrogen gas. What are the products here? When iron is reacting with steam, it will form Fe3O4 and hydrogen gas. Can you put balance the reactants and products of A. Have options are 4 here. Here we had only 1 mole. So we are making this one as 4 moles. Then how many moles of hydrogen gas will be released? 4 moles of hydrogen gas will be released. So these are the two reactions related for the activity to show metals are going to react with steam. The metals that reacts with steam. Metals that reacts with steam. Metals that reacts with steam. But now we are coming back to the concept. The metals that will react with cold water or normal water. Metals that reacts with normal water. Let us see here. Metals that react with normal water or cold water, here we can call. Don't think cold means placed in the refrigerator. It reacts with normal or the cold water. Now we have these metals, potassium and sodium. Potassium and sodium. Which metals will react with normal water? Potassium and sodium reacts with cold water or the normal water, we can mention. Let us write the equations corresponding for their reaction. There is no diagram for them to be represented. Potassium is going to react with water to form. Basically, whenever any metal is reacting with water, that will form a metal oxide. That so-called metal oxide will further react with water. Instead of making equation 2 steps, we are writing in a single step. Okay, children? Generally, metal when reacting with water, it will form metal oxide and that will release hydrogen gas. Again, this metal oxide will be reacting with water to form the metal hydroxide and that will release with water. Instead of 2 steps, we are writing in a single step. So, metal when reacted with cold water or the normal water like potassium, it is going to form metal hydroxide. What is it going to form? Metal hydroxide. Please observe potassium hydroxide. Here what it need to form? Potassium hydroxide. Metal is the potassium. So what is the compound that will be formed? Potassium hydroxide. We know the formula of potassium hydroxide. It is KOH. Along with that, it is going to release the hydrogen gas. Whenever we remember the point, highly reactive metals like potassium and sodium, they readily react with water to release hydrogen gas, as well as with hydrogen gas they release a high amount of heat. What do they release? High amount of heat. They release a amount of heat. So I am writing plus heat energy. Plus heat energy. Plus heat energy is, it is an exothermic reaction. What is this one? An exothermic reaction. Is this reaction a balanced equation? No. So let's start balancing this one. We have here potassium, water, we got potassium hydroxide, hydrogen and heat. But for the balancing purpose, we know potassium will show +1, hydroxide will show -1, and 1 and 1 crisscrossing, we had KOH. We had the KOH. So 1 potassium will react with 1 hydroxide ion. 1 potassium will react with 1 hydroxide ion. Our water generally to give H plus ion and OH minus ion. Means from one water molecule we are getting one hydroxide ion. How many potassiums have I chosen here? 2 potassiums. For one potassium we will need one hydroxide. For 2 potassiums we need 2 hydroxides. So we are using 2 moles of water. In the product we will have 2 moles of potassium hydroxide. How many hydrogens are present here? 4. Out of them 2 are used. Remaining 2 are released in the form of hydrogen gas. In the form of hydrogen gas. I am repeating the point once again. The metals of highly reactive series like potassium and also sodium. I will give the equation regarding sodium. So let's start working with sodium. How to write the reaction with sodium? See, the same potassium is having plus 1. Sodium also belongs to first group and it will also have plus 1. Like we write 2 moles of sodium reacts with 2 moles of water to give 2 moles of sodium hydroxide. To give 2 moles of sodium hydroxide. And also it will release the hydrogen gas and also with amount of heat, that is exothermic reaction. In both these cases, potassium and sodium are reacting with the cold water to form a metal hydroxide and they are releasing the hydrogen gas with lot amount of heat. This heat will make this hydrogen to undergo combustion. Means it will start fire or it will catch up the fire. Heat release is more, which makes the hydrogen gas to catch the fire, just to ignite it. Hence the potassium and sodium are not supposed to place in water because they will be catching the fire. They react with cold water itself. Now let us see the metals that are going to react with hot water. The metals that are going to react with hot water. The second, after the potassium and sodium, what the next metal we had children? Calcium and magnesium. Let us see about it. The metals like calcium and magnesium. Once we see their reaction, we are writing here metals that reacts with hot water. Please see, we are taking a beaker. What are we taking? One beaker. In this beaker, we have placed hot water. Some hot water. And we are going to place the pieces of calcium or magnesium in this hot water. What are we placing? The calcium or magnesium metal. Generally, metals won't float on water. They will sink to the bottom of the container. But here, once we place calcium or magnesium in the hot water, calcium, before you write any equation, try to know the compound that will be formed. Calcium is having a valence of calcium 2 plus. Hydroxide OH minus. Means 2 and 1 crisscrossing. What will form? CaOH twice will form. We already came to know one water molecule can give H plus ion and OH minus ion. Here observe, for one calcium, how many hydroxide ions are needed? 2 hydroxide ions are needed. From water we can get only one hydroxide ion. So when we are reacting the calcium with water, when you are going to balance, this is in the normal liquid state only. But we take 2 moles. In this case, the calcium is going to form calcium hydroxide that is dissolved in water. Calcium hydroxide that is dissolved in water. And it is also going to release hydrogen gas. Please see children, it is releasing hydrogen gas, but it is not releasing much amount of heat like the potassium and calcium. It will release some amount of heat, but not that much of heat released when potassium and sodium is reacted with water. So that released heat is not sufficient for the hydrogen to be ignited or to catch the fire. But instead of catching the fire, what happens is the released hydrogen gas will be stick around. I am zooming this one. This is the calcium metal. It was surrounded by hydrogen gas molecules. It is surrounded by hydrogen gas molecules. So, if the metal particle is come down due to its higher density, but this is going to be surrounded by more number of hydrogen gas molecules. Calcium atom unreacted will be surrounded by more number of hydrogen gas bubbles, which makes this calcium metal to float on water. Note the point here. Calcium floats on water. Because the released hydrogen gas surrounds the calcium metal, and thus this calcium metal will float on the water. One question will be raised: why calcium float on water? Because the released hydrogen gas surrounds the calcium metal. It makes the calcium to float on the water. Next, what is another metal we are discussing? Calcium generally reacts with normal water also. Just to bring here how its reactivity will be increasing, we are using the hot water. In the place of calcium, take magnesium. Magnesium reacts only with hot water. It does not react with cold water. Magnesium does not react with cold water, but it reacts with hot water. Magnesium reacts with hot water. Here also we are taking the same activity, like we have taken one beaker. In the bed placed some hot water and we got the magnesium. Magnesium valency is Mg2+. It also reacts with hydroxide ions in the same manner just like calcium to form magnesium hydroxide. For one magnesium, how many hydroxides are needed? 2 hydroxides are needed. They will be coming from water. It is going to form MgOH twice, that will be dissolved in water, and also hydrogen gas is released. Even in this case also, the magnesium will float on water. Why does magnesium will float on water? The released hydrogen gas will surround the metal and that makes it to float on the water. So now the conclusions are, what are the metals that are reacting with cold water? Potassium with cold water. The reacts are potassium, sodium and calcium. What are the metals that react with hot water? The metal that reacts especially with hot water, only with hot water, is magnesium. And what are the metals that are reacting with steam? Aluminium, zinc and iron. What does not react with steam? There are some metals that does not react even with steam. We have the least reactive metals like copper, silver and gold. They does not react with the steam also. Hence, the steam containers, they are made by copper metal. They are made by copper metal. So in this class, we have discussed about the reactivity of metals with water. There's cold water, hot water and also with the steam. Thank you children. In the next video, we will discuss how the metals will react with acids.